This video will help you determine if a game is fair or not. Chris and Jack are playing a board game with a fair coin and a fair number cube numbered 1 to 6. They take turns tossing the coin and the number cube. They then figure out the score. If the coin lands on a head, the score is twice the number on the number cube. If the coin lands on tails, the score is 2 more than the number on the number cube. If the score ends up being a prime number, Chris gets 2 points. If the score is not a prime number, Jack gets 1 point. Find the theoretical probability that Chris will get 2 points. So, we have to figure out, first of all, our sample space, and then use that sample space to figure out the score. So, looking at our sample space, we could get heads on the coin and a 1, heads 2, heads 3, heads 4, heads 5, or heads 6, and then tail 1, tail 2, tail 3, tail 4, tail 5, and tail 6. Looking at what the outcomes are, if we get heads, the scores, if I write it below our sample space, is twice the number on the coin, or on the cube. So if we get heads 1, the scores, and I'll just write them below the sample space, would be 2, 4, 6, 8, 10, 12. And then if we had tails on the coin, the score is 2 more than the number on the cube. So tails and 1 would give a score of 3, then 4, 5, 6, 7, and 8. Looking at those scores, if it's a prime number, Chris will get 2 points. So looking at the prime scores, we have 2 is prime, 3 is prime, 5 is prime, and 7 is prime. So the theoretical probability for Chris to get 2 points was, let's see, 1, 2, 3, 4 out of the possible 12 outcomes, which reduces down to 1/3, 0.3 repeating, 33.3 repeating %. Looking for the theoretical probability that Jack will get a point. He gets a point if the score is not prime. Okay, so looking at the not prime scores for Jack, the not prime scores for Jack would be all the other scores. So 4, 6, 8, 10, 12, 4, 6, and 8. So looking at that probability, so the probability theoretically that Jack gets 1 point is 1, 2, 3, 4, 5, 6, 7, 8 out of the 12, or 2/3, which is 0.6 repeating, or 66.6 repeating %. Okay, so those are our probabilities. Now they want us to decide, is this game fair? And explain. Well, the probabilities are not the same for each player getting some points, but they balance the unfair probabilities by giving Chris twice as many points as what Jack would get. So even though Chris is going to accumulate points more frequently, or Jack will actually accumulate points more frequently, every time he gets a point, it's going to occur twice as often as what Chris gets. So this game is actually fair. So it is a fair game. To really explain and prove it, let's assume they play the game, let's do 15 times. So assume they play ones actually do 30 times. So we expect for Chris to get 2 points. That would happen 1/3 of 30. So we expect Chris to get points 1/3 times 30, which is 10 times. Every time Chris gets points, remember, he actually doesn't get 1 point, he gets 2 points. So Chris's score would be 10 times 2, or 20 points. Now looking at a similar idea now for Jack. In 30 games, we expect Jack to get points 2/3 of 30, which ends up being 20 times. And every time Jack gets points, he gets only 1 point. So Jack's score would be 20 times 1, which is 20 points. So because their scores in the long run we would expect to be equal, that makes the original game fair. I hope this video helps. Let me know if you have any questions. Thanks.